Okay, so in this problem, they're asking us to construct a truth table for the statement, not P and if P then Q. So the first thing that I'm going to look at when trying to do my truth table is how many variables are there. And I see there's a P, I see there's a Q, there's two variables. So if there's two variables, I want to have 4 rows of my truth table. If there were 3 variables, P, Q, and R, there'd want to be 8. So let's start just by setting up the basics of the truth table. So I'm going to have my P's here and my Q's here. And in order to make sure that I get every possible combination of P's and Q's, I'm going to go true, true, false, false for the P, and true, false, true, false for the Q. Okay, so that gets me every single possible combination. So then I need to think about what else needs to go into my truth table. So I go and I look at my statement, and I see that I have this not P. Okay? Remember, if there's no parentheses, that not symbol just attaches to whatever is kind of the closest to it. So it's not, you're not negating anything with the and or anything like that. It's just on that P. Okay, so we're going to need to know what not P is in order to evaluate the rest. Okay, so we'll make that our red column. Okay, well, we also need to, there's got an and, we've got an if then. Notice there's parentheses here. So the parentheses tell us that we want to evaluate this if P then Q first. Okay, so let's do that. I'm not going to actually do it yet. I'm just going to put it in my truth table so that we're ready for it. And then now that we have our components, right, you can see that this and here, what's it joining? It's joining kind of this part with this part, right? You can see how those were kind of calculated first. So that's the final step, is to do, okay, fine, now that I have that, I can do not P and if P, then Q. Okay, so let's do our not P. So not P is going to be the negation of the P column. So whenever P is true, not P is false, and whenever P is false, not P is true. So here I have true, so that's going to be false. Here I have true, so I have false. Here I have false, so this is true. And here I have false, so this is true. So notice the not P column is the exact opposite of the P column. P was true, true, false, false. So not P was false, true, false, false, true, true. Okay, it's just everything is just what the opposite of whatever P is. Okay, so now let's look at our if P then Q. So if you recall, the only possible way to make a conditional false is if the first part is true and the second part is false. This is a problem, right? Because if P then Q says whenever P is true, Q has to be true also. And that's not happening in the circled one. In the circled one, P is true but Q is not true. So therefore, this conditional is false, right? That's the situation that makes a problem for us, right? If the beginning is true and the end part is false, that creates a problem for your conditional and it makes your conditional false. But everything else is true. Okay, so if P is true and Q is true, that's fine, right? Because all that we care about is as long as P is true, Q has to be true. If the first part, right, our P is false, that's fine. Because if P then Q only tells us that if P is true, Q has to be true. It doesn't tell us what has to happen if P is false. So as long as P is false, it's fine. It's not, we don't have any type of contradiction. So that's true, that's true. So the only contradiction is the circled situation. It's the only time we get a false. I know this is kind of the most conceptually difficult, understanding kind of why if P is false, then the conditional is false. But just think about that it's not contradicting this statement, right? The statement that I somehow circled in blue, but the if P then Q is, what it's saying is as long as P is true, Q has to be true. And the only way to actually contradict that is the circled one. So you get a false there, but everything else is true. And then finally, we're going to do our and. Okay, so what's happening with our and? We're looking at, here, if you look over here that I circled again, right, not P is one thing, and if P then Q. So those are the two things that I calculated already. So we're looking at this column and this column, and we're going to combine them with an and. So if you recall, and is true. It's only if they're both true. If there's a single false, they're not. Then you don't have the and part isn't true because you need to have this one be true and this one be true to have the and be true. So if there's a false, then you get a false here. Here's a false, there's a false, right? That's a false. So false and true is false. False and false is also false. But if they're both true, right, true and true, that's true. True and true is true. So that's your final truth table. Okay, and it tells you, what the truth value is of this statement in any given possible combination of P's and Q's.